Welcome everyone and welcome to the panelists. I have been so excited about this panel because what we have here are literally people who are pioneering India's effort in building foundation models. So I'm sure this is going to be a very exciting and interesting talk of where we are, what needs to be done, what are we doing well, and where do we need more support in various ways. So to the entire panel, my first question is, there's a lot of, this is a little bit of a polarizing thing across the world, whether we need sovereign models or we don't need sovereign models. Do we need India-specific models or we don't need, is it enough to take open-weight models and fine-tune them or tune them in certain ways? So I would like to ask all of you what your view is on, why we need to even go down the line of building our own foundation models in the country.
Right. So, yes, hi. First of all, very nice to be here at BTS. And I think, what we've seen is really, in the last 3 years, these foundation models have made, incredible progress starting from GPT to whatever it is today. I suppose it was Gemini things yesterday. And I think the capabilities of these models are growing dramatically, and also the kind of investment behind models is dramatic. So therefore, somebody will say, why don't you just use the global models and things like that? And there is a certain case for that in certain kinds of scenarios. That's something that's possible. But I think if we don't put an effort in foundational models, I think we'll become a digital model. That's really what. That's why we need to have foundation models. And what is really, I think there are obviously, if you look at models, there are two kinds of models, right? There are the closed models where you just have an API endpoint and you're calling models. And then there are the open models, right? The open models are where the weights are available and you host it yourself and you actually use those things. Now, the point even with an open model is really one of the things that's there is, and I think there was some things in research coming out of Anthropic, which actually said that even with a very small, if I actually had an open model which was made, where you can actually poison the model with a very small amount of data, and you can't understand what the impacts of that would be. And that's something which is very interesting because today, I think we started off with the llamas of the world and being the premier open source models. But today, if you look at most of the top open source models, they're actually from China. That's the fact that if you look at the best performing open source models today. And so therefore that's, of course, there are certain kinds of use cases where I think that fine-tuning an open model we actually have risks that we don't understand. But still, I want to say two more things. That the other reason why we want to have a foundation model is that when you look at the data that is used to train a model, right? I think that, for example, we don't know the exact numbers, but certain kinds of early open models we know. Maybe the data which was of Indian context supplied was sub 1%. Right? That was the data that was. So how do you expect a model where maybe sub 1% of the data trained was actually of Indian origin? Now we are obviously, the India mission has actually given us a charter with a foundational model. And when we are talking about, for example, we have we're going to be launching this model in the next couple of months, and it's a 120 billion parameter model with more than 17 trillion tokens, and out of which maybe 15%, 20% are Indian tokens. So that's the other part. The third thing I think is that this technology is so important. And it's so, I would say that if you don't know how the core of this technology works, that is starting from scratch, how to actually train a model. I think that it is something that if you don't know how to do that, you'll never know how to do that. And I think that from a strategic reason, that's something.
Once again, thank you for this fun call. So let me take this question more of a philosophical side. So of course, this question is not only for this technology. I've been asking such type of questions even when we have the International Supercomputer Mission. Do we really need National Supercomputer Mission? In fact, unfortunately, I would say that we were not so successful in supercomputing. Otherwise, we would have been the leaders for AI. Because that technology put us behind, and that is the reason we are behind in AI technology. Similar to that one, if we do not build our foundation model, as we already pointed out, we will not be learning how to do what, right? Know-how technology is very important. If we are not mastering the know-how technology of the AI today, we will be missing out the future technologies as well. We will be behind the future technologies as well. So from that perspective, irrespective of, because this question has been asked at many forums and answered by many different versions. But to me, right, if you do not know-how technology, do not know how to build the foundation models, then definitely the next technology, like the AI technology, we will be behind us. So from that perspective, we need the talent to build, we need the talent to know how to build the foundation models, and we can definitely innovate. Innovation is the key for any new technologies in the future. The startups, unicorns, we talk about all different metrics, but in order to innovate, we really need to learn the technology. To learn the technology, there is no best way other than by doing it. So from that perspective, more than what's the impact that the AI model is going to create, I'm talking about in future, we all want to have the technology, then we should be knowing this technology. That's my submission.
I think, thanks for having me here. Both my co-panelists covered the need of it, but I think the fundamental part as a country that we are in, AI is a necessity for the next 800 or say 800 million people. We are all in Bangalore. We understand what is happening in the global world. But the need of AI to people who are less privileged than us, that is something that we need to build. And it acts not like an adoption, but it acts like a necessity for people. Like for example, I come from a village which is around 200 kilometers from here. I still today, internet is still used for WhatsApp, YouTube videos, and some videos. But there are 100 different things that can empower people. And unless we control the whole tech stack, whatever Vivek said on data, he said on knowing how, unless you have all of this and with an intent to solve for the class that will benefit a huge amount of AI, right? I mean, we all have definitely adding efficiency in our conflicts, but there is a tectonic uplift that happens to people who are deprived today of various things. I mean, hardly in my village when I go by, there are so many government schemes that are there, but they don't know how to use it. It could be lack of information, it is the way they access that information. I think where foundation models that are the need for it is to empower such people, and I think for that we need to build a foundation model that is truly Indian. The second part of it is the cyber security and the defense security. And we are growing, we are 4th, 5th largest nation, and unless we need to protect our assets, unless we control a model in and out, we are prone to all sorts of attacks coming from different parts of the country, from the world. So I think these are the two biggest needs for AI for a country like us. One on our aspiration to grow bigger and bigger, and other is how do I uplift the rest of the citizens to the next stage where the world is progressing.
Thank you. Actually, I will, ask you the next question. Since you have been doing this, you've been creating speech models long before generative AI was a thing, right? Like just in the start when LLMs were becoming the mainstream technology or model to go to. So, can you talk a little bit on how the technical part of moving from, the machine learning LLM kind of phase to now with generative AI, how things have changed technologically, and how technically, scaling, because you mentioned about scale, how technically scaling is either more easy, difficult, and where do you see the challenges in that?
See, when we started building, we were building on classic ML models, deep learning models. Today, it is all different types of accurate transformer architectures that you use, and also data sets that you are trying to get a good speech system process. I think this is way back in 2016. It was about 10,000 hours, so you could get good speech system, and you would probably hit about less than 8-9% word error rate. But again, all of this were done on singular language. A country like India, even then and today, you need a multilingual, you need a code switch language. Probably most of us here talk in 2 or 3 languages and we need code switching. And you need a much real-time efficient system. So challenges, with the whole, I would say, even without calling it as LLM, with the whole transformer architecture and attention to the transformer, there was a significant progress done on speech. And that fused with your LLM layer makes the understanding more simpler. But again, you hit challenges of scale. Today we do, at any given point of time, we largely work in audio voice AI space. On a good day, we handle close to 10 crore words per second. So that means about 1 lakh audio calls hitting my systems every second. I need to give a response time less than 150 milliseconds at the audio layer. And this could be multilingual, it could have huge background noise coming in. People would put their phone on speaker and would be talking from far. You need to handle what do you call as far field in audio, things like that, right? I think the complexity of model got complexer, and your model got intelligent in terms of handling. So we took approach where earlier we had a separate denoiser block, separate far field block, etc. But now again we are making the networks intelligent that all of them are fused. And we also look at this at the training level itself, so that your training data is also very similar to your field data. Classical thing, I remember one experiment which I think IIT Madras tried. They built a good model, went out, put it to public for farmers, and first word did not fail on telephony network. So you are very good at a 48 kilohertz or a 16 kilohertz when you are talking to your laptop, but when you go to a telephone line compressed at 3G or 2G or even 4G networks at 8 kilo, sub 4 kilohertz data coming in with huge background noise of a car or someone singing behind. So these challenges have become, with the neural nets, these are much easier to solve, but these are challenges that you need to solve to handle the AI systems that can actually make a human-like conversation with a user.
Yeah, that's very true. Actually, I remember ages ago, even before 2016, there was this initiative by one of the companies to put ASR-based things in Indian railway station, and it completely failed because the background noise, in Indian railway stations is something that those models had never seen or handled before. So, yeah, that's a fair point. So, Professor Shashi, your focus is on scientific models, right? Like to advance scientific capabilities, etc. In what I would call the West, there have been a lot of very significant breakthroughs using generative AI in the field of biomedical things, for example, genetics, material sciences, etc. So how do you, this requires quite a lot of deep research and scientific data. So do you think to build a scientific, like how are you even going about this architecturally as well as data-wise, like so that it actually is something that India can benefit for, if not in the very short term, then in the longer term?
Sure.
So first let me explain, or at least try to, on a high level, what is really the scientific foundational model that she's talking about, or what we are trying to build. So if you look at the existing large language models, these large language models are mostly like probabilistic based, next token predictions based on the probabilistics. But what is the biggest challenge is importing the scientific knowledge. And for example, I want to have the response should be physically consistent, mathematically verifiable. So those type of constraints, you cannot put it in the existing large language models because it is not meant for that. On the other hand, what scientific innovations or scientific discoveries we really need is the response that we are going to get from these foundational model really should have like the physically verifiable responses, and as well as sometimes the causal responsibility. I need to have the reasoning out. So it is temporal and as well as the spatial inferencing should also be validated. For instance, when I increase the temperature in particular location, right? So how this reaction is going to be, right? Reactives or nucleation is going to be. So these type of reasonings are ingested into the large language models. So when you want to bring such a type of responses, then definitely we need to build a foundational model which is also of a scientific capability, physical reasoning capabilities. So what I see from the architectural point of view, of course, the transformer is exceptional, doing well for linguistic applications, whereas when it comes to the reasonings, especially the scientific reasonings, what we are missing is more of like the symbolic reasoning. What we are missing is, for example, the encoder type, specifically for the equations or the mathematical formulas or even the physical relationship. So the encoders that's exclusively for encoding the equations. For example, if you go to the Navier-Stokes equations, if you take the energy equations, you cannot mix match. It's not the next term, next operator is not a probabilistic operator. There is a physical meaning to it, there is dimensionality analysis comes into it. So we cannot, the encoder cannot go is convert the set of equations as a set of tokens, but we have to embed some physics into it. So those are the challenges I see are missing components in the existing transformer models. This is where at Zentic we are really focusing on to add to these transformers so that, and then I bring the data set of a scientific data set, either synthetically generated. So even to generate synthetically, what I really mean is scientifically computed data set. It's not like hallucinated or generated from the LLM models. So you have to create the data set from the physics informed approaches and use the data sets, train on these enhanced transformer or enhanced foundational model architectures, then we will be able to bring the capabilities. So why we really need, why are we looking from this perspective? For instance, India, it's, when you build about the foundational AI for India, it cannot be about only for languages and the general purpose applications. Of course, those are very much needed, but we also really need to take care of how to accelerate the scientific discoveries and can AI solve the engineering problems. And if you look at India's major challenges, biggest challenges, I would say that right now it's energy, EV we are talking about, and then how can I accelerate the advancement in the engineering, manufacturing, right, climate, and you keep on material discovery and so on. So those are all the challenges that could be addressed with this foundational model. This is how we are really building it.
Yeah, I completely resonate with what you're saying about like India's challenges and a lot of, because you go and talk to people who are in the manufacturing field, who are working in industrial things, and a lot of them are still very unsure of how they can use AI beyond kind of like a user-centric productivity tool, but like in a deeper sense. I will come to this whole deep tech kind of a thing later, but Vivek, you've seen it all. You've seen how, stacks are built in this country. You've been involved with Aadhaar in the past. You've helped build, the India stack, the first India stack, if I may say so, kind of. So what, according to you, in AI, like, what are the things that you can actually bring in from your earlier experience, but what are things that are absolutely new when you start thinking about building an India stack, based on a foundational model that, like Sarvam is building?
So I think in the last 15 years, I think we've done lots of interesting things in the India stack and building, creating some of these population scale systems. I think the interesting thing is I think AI is somewhat orthogonal to that. In fact, but the fact that these large scale systems exist means that if you actually build the right kind of AI, these things can accelerate, the adoption of these things can accelerate them dramatically. If you look at what we did in, and actually Aadhaar is somewhat of an exception because it is deep tech in that sense, but most of India's stack is actually creating the data pipes, defining the interfaces, and scaling things so that these various systems can talk to each other. And when these systems talk to each other and systems exist at scale in the country, you can actually bring out new things much faster. And AI is an accelerant to this. And I think that if you see that in each one of these systems, I think AI will play a very significant role, but the fact that these systems exist will basically allow, and I think I resonate very much with what Anant has said, right? The reason that we have to get every person in the country leveraging this technology because it is going to make a difference. We talk about the digital divide, right? The people who don't have access to digital technologies and I think the AI divide, if we not careful, can be much worse than that, because we all know that in our lives we can have significant efficiencies and improvements in what we do, but then that needs to go to everybody. And the promise actually should be, right? How does everybody get access to good education? How does everybody get access to high quality health? And I think some of the systems that we have built, that thinking and leveraging AI in that concept is actually something that combination for the first time we see that I can see that light in the tunnel, that life can actually be simpler for people, right? I think we are not there yet. Trust me, we are not there yet, despite being in sync. But I think I sometimes say that in UPI, for the first time, we feel that something is better in our country than in other parts of the world. But most things are still hard, and I think AI has that opportunity to make that simple for everybody in the country, and that's the where we must focus to how do you actually make this impact happen.
So I was in this first session, the inaugural session, and I was listening to the panel there, and Priyank Sarup made a very interesting point, right? He said that we need less of unicorns. I'm paraphrasing him. He didn't exactly say that, so don't quote me, please. But he said something to the effect that, unicorns are not the thing going forward. We really need to have deep tech focused startups. Right? And I've, in my conversations to folks around this whole ecosystem in India, there seems to be this thing of let's not only solve use cases, but let's kind of solve deeper problems, which goes back to what you had earlier said. My view on this also is if in 3 years or 4 years time we are still solving the same use cases, then we have in some sense failed, because we should have solved those use cases by then, right? So in that sense, where do you think, if we did have this patient capital that everybody is talking a lot about, in each of your fields, each of you, if you can answer this, where do you see this deep tech focus and this patient capital helping you take the technology forward, not just solving, not just making more applications per se?
Maybe should I start? Yeah. So I think maybe I'll go back to the previous thing. I think the important thing is not to focus. While use cases are very important, they actually show how something is useful. But I think having platforms is something that where you can actually see that, how you can actually scale and do things, greater things over time. And I think obviously when you're trying to build more foundational things, it does take time, it does take money, and I think that, I think India is, I think both of those, I think some of these things are changing. There is obviously more funding for deep tech than before, but still I would say orders of magnitude less than it should be, because these technologies are so important, right? I mean, I think that, I think that while many of the things that we've done, that have done are good, but even if there could be even a couple of orders of magnitude more, right? I mean, for a country of India's size, there actually can be much more. And when we have to figure out how to make sure that those things actually happen, right? I think capital is definitely a key to understanding these kinds of things, because it gives you the freedom to solve the problem in the best way rather than give the band-aid solution for the, for what you need to actually make revenue the next quarter, right? Which in deep tech is very, very important, because in the long run, those which have the solid foundation are the ones which are going to be successful.
Yeah, so maybe I will put the previous phrase in a different way. When I talk about the unicorns, yes, you are right, but I took it like we have to build a unicorn, but the value should be for your product, not in the inflated 5x, 10x. So this is where we should really build a unicorn, right? The product should be actual value, right? That's the value that you are built. Coming to the funding, yes, of course, there are always challenges, especially in the Indian context, to getting into any new technologies, getting the VC fund, or even to start such a type of which really, one is the compute, second is the talent, and third is, for instance, the huge capital. These three are biggest challenges. Of course, if you look at the Government of India initiative, especially India mission, I would say that icebreaker, I would say. So there were the hesitation from the Indian VCs group as well, whether we should invest or will this technology will be quickly taken over by the US or other countries so that our investment will go. But the bold move from the India AI mission to, yes, we are going to initiate it, and then those initiation, I would say the first step, I believe that it has opened the doors for many. And I see at least now some support from the VCs to the such type of deep tech startups. Of course, the deep tech startups also really need some time. It's not like 3 years, quick services kind of sectors we cannot expect. And that's the reason, for example, ARPAC is one of the examples where we are incubated. So we get the seed grant, and then especially the lab support and also the advisories. So patience is the key. But at the same time, as you mentioned, 5 years, some product, right, we should really focus on, especially when it comes to the deep tech. And if you are looking at the service as a deep tech, I see a big challenge here.
Okay, I have a contrary view to all of them. So India, by our culture, if you look at R&D spends of any large corporate, I bet it is less than 3%. So India is a value-driven market. Yes, there has to be a large capital, which is a patient capital waiting. But in India, it is not accessible to most of the startups. I think what has worked for us, we have been profitable, we have been successful to a small extent, is, as I said, we took a use case. But to solve a use case, either I can be a wrapper on some API or I go invent. That's the innovation. So India looks at value innovation. So if you are innovating and you have a long vision of, say, I'm building something fundamental which can add value. It can be used for one use case, but it is creating a platform that I can replicate into 10 other use cases, right? That sort of fundamental research in India has money today. At least this is my experience of trying to pitch to multiple VCs in the country. But I think, and this is what has been in our culture, like in India we look at frugal innovation. This is worked as in multiple cases, things that what DRDO and ISRO have done at far lesser spend than what global companies like NASA or SpaceX is doing, right? I think India has an potential to innovate. There is now, as he said, India AI for us is also a boon that we get close to 1,500 odd GPUs to pump up and run our models. So this sort of government waking up and saying, hey, I need to support startups to do. I mean, this is something that's happening great. It is changing. But again, for that to become like in the West, like you go, you have an idea, you raise 30 million with an idea over a deck. I don't think India is going to get there in next 10 years. India requires value. Every pie is measured by the value it gets out. I think this has been culturally what the country is, and I don't think it is going to take a tectonic shift in next 5 years. We might cry, we might do all of those things, but finally when someone is putting a rupee on table, he is going to ask you, boss, what is my IRR, what is that I'm going to get? They're ready to wait as long as you're showing value. I think this is completely, as a country, we are looking different to what is in the West. So I think this is my view on it. Yes, as you said, there is huge need for capital, but capital comes where there is innovation and a value. And probably you might not see free money coming in. You might do first round, but you will get stuck in second round unless you show your value. So I think this is where I see where the...
Of course. Now, just to change tracks a bit to my favorite topics, which is evaluation and then safety. So, starting with you, Anand, because like you've been doing this for a long time, and I'm sure you're as frustrated as I have always been with word error rate as any benchmark for anything, right? People still talk about word error rates, etc. So, and there is no easy way, to evaluate Gen AI models, right? Like applications we can do, user things, etc., etc. How do we evaluate models? So, how have you gone about, not just on the accuracy, precision recall kind of measures, but also on the impact and usefulness kind of a thing? Like, how do you evaluate? And this is a question to everybody.
Sure. I think a lot of our, the way when we started, we were talking WER benchmarks to everyone. It made no business sense. At least what we do today is we run some sort of field trials. Field trials can start within an enterprise or it can go out. And then we see a business outcome to it. There are technical challenges, I'll get into it. I don't want to get into the accuracy errors. Those are things that are being measured. But typically, what is the impact that it creates? We were doing a campaign where we used to help mothers in different trimesters of their pregnancy with like an intelligent voice bot, and this was run in UP, multiple villages, right? The impact there was, hey, I had this question, did your assistant answer? So then we said there were some challenges initially. On the back end, this was multi-phases. In the first phase, we had a bunch of doctors who used to feed in the answers. Then we used to do an outbound call back to the patient and said, hey, this was your query. So at that point, we were just doing a transcription, capturing the audio. This is like 4 years back what we did. And we used to relay back them the answers. That led us to build a questionnaire bank of 1 lakh questions, which people ask across different phases. What we did then is we made ASHA workers more intelligent, enabled this set of questions to them. And whenever there were a meeting between mothers and ASHA workers, they used to call together and get answers. So the impact here we measured is on this set of questions, what is the accuracy level that I could give back, whether my answers were deterministic. So you could go into technicality of saying hallucination, this one, but that's a different problem to solve. But in use cases like this, it is like, how accurate is your system able to understand even the question is half broken? Can you communicate back a pre-vetted answer which was given by a doctor? So based on different applications you deploy, we see various measurements coming in, but fundamentally to the core, it all boils down to your word error rate, how do you handle noise, what is the hallucination factor that is coming in, how do you contain the RAG on your data set, things like that, for which we have some deterministic benchmarks that you keep running. But from an end user perspective, this is what we have been doing in the past and we do. I think with this we know fairly that wherever I am confident. Also, in some cases, we do a mix of confidence-based answer. Wherever I am not confident, I try to bring a human in loop, or we say we'll get back to you. So that, again, it depends on use cases again. So you can configure your system to handle scenarios based on this.
So Vivek, I would like you to answer this in a different way. Like, earlier, the benchmarks and the evaluation things that we ran, they had very little India-specific content, right? And the benchmarks got contaminated the minute you used them, right? And the thing to make them India-specific was to just translate those into Indian languages, which also did not work. Yeah. But now, in just recently, OpenAI has put out this India Q&A. AI for Bharat has put out the arena. So, do you find those useful? Have you got your own thing? What would you want from people who are working in the evaluation space? What would be really useful for foundation model building for India? If you had a wish list of sorts.
So I think, certainly what both OpenAI has put out as well as what AI for Bharat has put out are certainly improvements to what existed before. But I think the point is that still, I think there is too much benchmark hacking, right? In the sense that, and the benchmarks are not representative enough of real things. So, I'm actually kind of going a little bit towards what Anand is saying, but I want to say it a little bit more formal way, that if you actually had something like you may have a base model, and then you have a use case, and you're looking at the distribution of data in that use case to actually leverage a benchmark, then that's much more meaningful, because then for that particular thing, you can understand whether the whether the business outcome really was achieved, right? Because as I said, I think that word error rate and character have no meaning really in today's world, and I think it is really whether the outcome was achieved or not. And I think that it's actually now much easier to create an in-distribution benchmark for a domain or a use case specific situation. And then you use that to measure the performance on that. I think that's probably the most effective way of saying that there is actually value to the end user in using the model, right? And so therefore, having more narrow benchmarks, right? Well, I think I think that we have whatever, the equivalent of all the standard benchmarks in Indian languages should be there. That's a I would say is hygiene. We need to have that, and unless we have that in languages, that will also direct the direction in which people are going. But I think having actually much more domain specific and intent specific benchmarks. Even you look at, when you're looking at conversations and things like, you look at things like tau square bench and things like, even they are not real as to what really is happening. So therefore I think, we actually create benchmarks too, so that we are not flying blind in these kinds of things. But having everything in Indian languages in the Indian idiom is something that is obviously much better and also much easier today than 3 years ago.
That's absolutely true. Professor Rashid, for scientific models, the benchmarks are at a different level altogether, right? They're much more complicated. There's a lot more reasoning, inference, etc. involved, right? Like, so how do you benchmark or propose to benchmark what you're building?
Yeah. So when it comes to the validation and benchmark and as well as the safety, that's another point that you talk about. So I will take one by one, right? When it comes to the validation part, first of all, we have to understand, right, any AI model or any AI system that we are building is an iterative process, right? So that the one component compared to the traditional software development, compared to the AI, what's an additional component that's part of the AI component is the continuous monitoring. So we need to have a continuous monitoring mechanism. Then we talk about the concept drift, data drift, and that's where the validity of the model comes. So when you talk about the accuracy and the validity, it is the responsibility of the developer, right? So then it's a continuous process over a period of iterate and build. On the other hand, when it comes to in particular to the scientific, how to create the benchmark, how to validate the model, though its outside world looks very complex than the LLMs and so on, but actually it is not the other way around. So the validation part comes from the physics. So if at all the response which I'm throwing, any response coming from the foundational model, whether it's confined to physical laws or not, whether it satisfies some certain dynamics or not. So we have already proven dynamics, proven physics behind it. So only thing is like based on that application, we have to develop the benchmark data set, benchmark data to validate that. So creating those benchmark validation is not so complex as the language one. So this is where I see it, right? We have at least some edge or advantage building the data set. On the other hand, when it comes to the safety part, right, safety is not only the developer's responsibility, the user's responsibility also. We can build like whatever the equipment and whatever the model that we build, but the question is how the user is going to get used to it and for what the user is going to use it. So when it comes to the safety part, then it's a responsibility of three groups or three entities. One, of course, the developers must put some guardrails so that it cannot be easily broken, AI models cannot be easily broken and so on. The second responsibility is as a user, right, I should be educated for what I should use, what I shouldn't use. And the third responsibility is what is the policy, right? If something goes wrong, something has mistaken, so what's the policy do that? So it's basically this, when it comes to the safety, it's a tripartite responsibility from the government, safety policy, AI policy, and as well as the user's responsibility. So the benchmarking policies and safeties put together, right, I think we really need to get it evolved over a period of time. Then only we can think about the benchmarking and safety over a period.
Thank you. I'll open it to the audience for a couple of questions before I ask my last question. Someone here with the mic? Yeah. Can you pull around who want to ask questions apparently? It also, yeah.
Hello, is it audible? Is it audible? Yeah. So considering recent Sam Altman's remark, it's a totally. How about now? Yeah. So considering recent Sam Altman's remarks that it's totally hopeless to compete with us.
I can't hear you.
We are. How about now? Yeah, perfect. So considering recent Sam Altman's remark that it's totally hopeless to compete with us on the training the foundation models or something like that. So what is the biggest challenge in building the foundation models? Say be it cost, compute, or talent, or the core tech stack. So what's the thing and why?
I think all three you said.
Yeah, all three is the answer.
It's unanimous, all three.
Hi, thank you for this really interesting talk. My name is Sugandh and I'm the founder of an edtech startup. My question to you is that given the shift in how we are approaching or looking at AI models, from it being an efficient AI model to being, is it an innovative AI model? So from solving for redundancies to now pushing the frontier of human knowledge, that's the arc that I observe in the way AI has changed over time. So given that shift, where do you see it moving next? Where does it lead us next?
So I don't know. I don't know how to, that's a big question, but I think that I personally believe that everything we do is going to change, and I think that no matter what you're doing, it's going to be completely different 5 to 10 years down the road. I mean, I think that's how the scope of it. You are entering a brave new world.
But and also, if you need a popular answer, of course, we are moving towards the AGI. All right, so that's the direction. But on the other hand, artificial general intelligence, basically, right? So on the other hand, right, these AI skills are going to be like, for example, 20 years back, knowing typewriting, or people used to go, right, for typewriting classes certification. Typewriting is a basic skill or additional skills one used to occur. So after this laptop, computer and other thing, nowadays like typewriting is no longer like an additional skill, it's a default skill. So similarly, what I see is the AI today, it looks like I have to acquire this additional skill, taking some upskilling and so on. But where I see is when it starts mingling, when it starts integrating with our day-to-day life, I'm going to see that AI, whatever we are using it today, it will be a default knowledge that we should acquire. This is where I think in an immediate time or immediate thing we are forcing and moving on.
Yeah, sure. Am I audible? Yeah. So thank you for your talk. My question is, myself, Dr. Pavana Pradeep. I have PhD in postdoc from USA. My question is for Dr. Vivek Raghavan. So along my research, right, I have been reading about these fascinating LLMs. Along with that, I have been studying about the carbon footprints of these LLMs, like enormous data trained and even at inference scale. So my question is, how does India's foundation model, like from Swaram, is taking initiative to reduce these carbon footprints and making Swaram as an ecosystem, you know?
No. So firstly, thank you for your question. I think it is definitely a relevant question because, as you see, people are building bigger and bigger data centers around the world. Maybe not so much in India, but I think the focus that has actually been happening is that, and from a model builder focus is, what is the strength you can build with a model as small as possible? And we are getting more and more efficient about how the models are, both in the training of the models as well as in the inferencing of the models. So compared to, say, something a couple of years ago, we're probably at least an order of magnitude more efficient, and then you figure out what is the right size of model that you need to actually solve what kind of problem. So many of the problems may happen in the edge. So I do believe that there will be a lot of innovation that will focus by this thing on how to make these models more efficient in terms of more energy efficient, and that typically also means efficient in terms of cost and other things. So I think that will happen. But there are two sides, right? The other side, we're building bigger and bigger models, and I think that. But I do believe that I'm not one of those people who believe that this is going to be going to hit an energy singularity here. Yeah.
Thank you.
Just one last question here because we are out of time. Yeah, just one.
Hello everyone. Very good morning. I'm Saravana from Superdome AI. I'm the co-founder of Superdome AI. So the question here is, one side we are talking about building a super big models, LLMs, and having 80 billion, 1 trillion parameters and all those things. But the other side, when you're going to put all the knowledge into single model, and at the end of the day, we are going to build some applications for some particular use cases, some industries, right? So there is a concept of SLMs, right? Small language models. So how we are going to diverge from, so one area we are going to make the LLMs stronger and stronger. Meantime, when you're going to build some agentic apps, we need a lot of SLMs, which lot of knowledge on that particular domain. So how the foundational model teams are going to approach that, and what's your take on that?
So I can give an answer of what we are doing. So within banking domain, which is where most of my business is, we have come to sub 1 billion parameter models. We do it, we call it as our own SLM models. So essentially, there are two phases to think, even answering her questions, right? One is you build larger models. Within larger models, again, you have a model of experts that you are trying to do. I think strongly we go with that mode where you have experts trained for certain specific data or specific task. Same on the SLM side itself, you bring in with certain capabilities distilled out and again sort of fine tune or adapt it to a particular domain, and you can, that's a model of expert for that domain, which can coexist in your larger model, but you can also have a version. And it's not only for an application specific, but you see a lot of things evolving on the edge. So this can go into your edge devices like phone or handheld devices, even your laptops, etc. So there is a lot of work happening on it where you contain your training data, you contain the capability of it, etc. and build it. I think a lot of research is happening on it.
So basically when you're training your foundation model itself, you're also thinking of how this can be broken down into multiple SLMs?
Yes.
Yeah. So one way to do it, one way to think about it is, that, you always can take a large model and distill it into a small model, especially if you are narrowing the domain of what your task is. But the point that you want to do is that if I'm an application builder, I would typically try to set up my applications always easier to use a larger model to begin with. But if I know that I'm going to use it millions or billions of times a day, I better make a small model to actually make that happen efficiently. So these are standard things of distillation of models. Is something that especially when you see that something is going to become high volume, then you end up doing those kinds of things. And kind of automated methods of doing that are also very key to actually building efficient agentic applications.
So we are out of time, so I just have one last question. Everybody, just one sentence. In 5 years' time, what is that big technological problem that you think India needs to solve to be at the top of the AI ladder? Just one sentence.
So to me, right, especially when it comes to the strategic applications, the defense and the strategic applications, we should be independent of foreign technology. And through AI, I believe that we can become an independent nation in terms of the dependency of the foreign technology for the defense applications. This is where I see it's a primary achievement that we can do it in the next 5 years.
I kind of agree with Shashi, but I think what I'll say is that this technology is so important. If we are giving access to this technology to all our citizens to do everything they need to do in real life, that is really the success of it.
I would say, I would dream that every citizen would have his own assistant, which is completely personalized to him. It could be physical, it could be virtual, but I'm talking including a humanoid. Like, it could be as good as that. I think you'll see, it could be a device that's your assistant that understands you better than anyone, and it helps you with everything you do.
Thank you, Anand, Professor Shashi, Vivek. Thank you, everybody.
Thank you. I request all the audience to give them a big round of applause for all the panelists for the very informative session.
To stay informed about the startup ecosystem, subscribe to My Startup TV.